In this video, I'm going to talk about number bases. Number bases. So, digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, they are used to represent numbers. The placing of the digits shows their value. And when we talk about place value, we have values like 10,000, 100, 10,000, like that. These are place values. So, for example, 3,706, it means 3,700, 0 tens, and 6 units. So, in terms of expansion of this number, we know that this is 3 what? 1,000, that is 3 times 1,000. 700, that's 7 times 100. 0 tens, that is 0 times 10. 6 times 1, and because we have 6 units, so it is multiplying 1. 6 times 1. Then 1,000 is what? 10 raised to the power of 3, because 10 multiply itself 3 times. That is 10 times 10 times 10. So it's 10 raised to the power 3 for 1,000. Then for that of 100 is 10 raised to the power 2. And that of tens, you have 10 raised to the power 1, which is 10. Then that of units, you have 10 raised to the power 0. Any number that have the power of 0, that is raised to the power of 0, is what? 1. Is the same thing as 1. Now, looking at this expansion, since this method is based on powers of 10, you can see that it's made of powers of 10. You can say that this is a base 10 system, and this is the most common one. This is the most common systems that is being used. Then also in base 8, we have other base. In base 8, 36 means 3 eighths, 6 units. It means 3 eighths, 6 units. Then why 247 means 264, 4 eighths, and 7 units. That is how to expand it. Now let me explain why it is 264. 264, it is because we have 8 squared. 8 squared, and 8 squared is 8 times 8, which is 64. If you look at the base 10 system, you observe that the counting form of the power is from 3 to 1 and 0. Are you seeing it? From 3 to 1 and 0. So from this number that we have here, if you want to follow it all based on the base 10 power arrangement, you will see that it will be 0, 1, 2, which means that our base, which is base 8, will be squared. And if base 8 is squared, it gives what? 64. So that is why we say that this is 264. 4 eighths, because 4 is multiplying 8. Then 7 units. 7 is multiplying 1. So 2 times 64, 4 times 8, 7 times 1. This is the expansion of this number that is in base 8. This is base 8 expansion. So in this case, we observe that 2 times 8 raised to the power 2, from what I explained, why this is 264. 8 raised to the power 2 is 64. That's 8 times 8. 4 times 8, that is 8 raised to the power 1, which is what? 4 times 8 raised to the power 1. Then we also have 7 times 8 raised to the power 0. 8 raised to the power 0 is 1. 8 raised to the power 0 is equal to 1. From what I said before, that any number to the power of 0 is 1. Any number to the power of 0 is 1. So this 8 raised to the power 0 can be the same as 1. So since this method is based on powers of 8, it is called the base 8 system. Call it the base 8 system. That is, all these numbers, all the base that we have here is what? 8. If you check the base 10 system, the base you have here is what? 10. So we are going to do an expansion an expansion of numbers in powers of their bases. Based on what we've done here, for you to expand numbers in powers of their bases, and you are able to understand that the arrangement form of the power is from 3 to 1 and 0, which means that when you are representing the power, your powers should start from 0, 1, 2 and 3. That is, it will start from 0. From the end, the power starts from 0, continue to increase from the end. So, and that is what we are going to do here. Now, the first thing to do is for you to multiply 2 by the base. 2 by the base. So we have 2 times 6, 5 times 6. That is, each of these digits will multiply the base. This is a simple way to expand. 2 will multiply 6, 5 will multiply 6, like what we have here. 0 will multiply 6, 2 will multiply 6, and 4 will multiply 6. Then from this expansion method that we explained here before, you see that the power starts from 0, and that is what we are going to do. So we start from 0, 1, 2, 3, 4. So we are able to what? Expand it in powers of their bases. Then why we proceed is to explain that 6 raised to the power 0 is 1. Just always know that any number to the power of 0 is 1. So we have 2 times 6 raised to the power 4 plus 5 times 6 raised to the power 3 plus 0 times 6 raised to the power 2 plus 2 times 6 raised to the power 1 plus 4 times 1. Now take note of this, that any number raised to the power of 0 is 1, which is 2 raised to the power 0 is 1, 3 raised to the power 0 is 1, 4 raised to the power 0 is also 1, and so on and so forth. Now I want to expand number that is in base 2. I want to expand number that is in base 2. How do you expand number that is in base 2? What you will do is you are going to use each of the digits to multiply the base. And what is the base? The base is base 2. So 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2. Then from what we did earlier from the first one, you are going to start writing your powers on the base. Start writing your power on the base from 0, 0, 1, 2, 3. You are able to expand in powers of their base. Then we can also continue by saying 1 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 1. Why do you have 1 times 1? 2 raised to the power 0 is what? 1, from what is being explained before. That any number to the power of 0 is 1. Now I'm going to talk about binary numbers. Binary numbers. Numbers that consist of 0, that is the digits, is just only 0 and 1 that you will see there. We call them binary numbers. Example, we have 101, 100, 1011, and so on and so forth. This is how to place the place value system for number base 2. This is the place value system for number base 2. We have the 8s, 4s, 2 units. Now you can see how this is being explained. 2 raised to the power 0, it gives what? 1, a unit. 2 raised to the power 1, it gives what? 2. 2 raised to the power 2 will give what? 4, which is 2 times 2 will give 4. 2 raised to the power 3 will give what? 8. 2 times 2 times 2, that's 8. So this is now being explained like this: 8, 4s, 2s, 8, 4, 2 units. So this is how to present the place value in the binary system. Now we're going to look at how are we going to convert base 10 to base 2 and base 2 to base 10. It's very simple thing to do. Convert 30 base 10 to a base 2. What you will do is you are going to divide the base 10 number. You are going to divide the base 10 number by the base that is given, which is what? To base 2. They say convert to base 2, so you divide by 2. If they say convert to base 3, you are dividing it by 3. If they say convert to base 5, you'll be dividing it by 5. So for this problem, we are converting it to base 2. So 30 divided by 2 will give 15 times, and there is no remainder. If there is no remainder, you write 0. Now 15 divided by 2, it is what? 7 times that I can go. and there is a remainder. The remainder is what? 1. 3 divided by 2 is what? Sorry, 7 divided by 2 is what? 3 times, and there is a remainder 1. 3 divided by 2 is 1 times, remainder 1. Now 1 cannot divide 2. So what we'll do, we'll take the remainder to this place. So that is why we write 0 remainder 1. We take the remainder to this place. So 30 base 10 will now be, your answer should be from the end, from the last. That's why the arrow is drawn. For you to write your answer, you start from the end. 1, 1, 1, 1, 0. So 1, 1, 1, 1, 0 has been converted to base 2. Lastly, convert 1, 1, 0, 0, 1 base 2 to a base 10 number. Convert 1, 1, 0, 0, 1 base 2 to a base 10 number. Now what will you do here? We are going to use the same technique we used during the expansion in powers of their bases. That is what we are going to use for this problem. Which is, we are going to use each of the digits to multiply the base, which is 2. 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2. Then, from the arrangement, we find out that the power will start from 0 for the power. That is from 0, 1, 2, like that. So it increases from the end. The power increases from the end. So we start from 0, 1. For the base, not for the number, the base, which is 2. 0, 1, 2, 3, 4. Here we have 2 raised to power 4, and 2 raised to power 4 is 2 times 2 times 2 times 2. 2 raised to power 3 is 2 times 2 times 2, and that's what? 8. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 2 times 2 is 4. 4 times 2 is 8. Now, any number that multiplies 0, is 0. 0 times 2 is 0. Then 2 raised to power 1 from the expansion that we planned, you see that 2 raised to power 1 is 1. So 1 times 1 gives 1. So when you plus this 16, 8, and 1 together, it gives you 25 base 10. Thank you.